Hello, this is a video to help you review your worksheet on 4.1 to 4.3. So you should have already done your worksheet. I'm just going to go through and explain things. So the ideal usage of this, in my opinion, would be to do the worksheet, to look at the answer key on Schoology, and then to be watching the videos for the problems that you got incorrect, just to make sure that you understand why. So in part A, the thing that makes this not a polynomial is the x to the negative 3. You cannot have an x with a negative exponent and be a polynomial. So you can have that in math, you just can't have it be, it's not a polynomial, then it's something else. This is the violation in B. You cannot have square root of an x in polynomials. The thing that is in violation in the next example is this guy. You cannot divide by something that has an x in it. So it's not just dividing by x, but even if I had division and like x plus 5, or if I had division with an x to the 4th, anything that had dividing with an x, that is not a polynomial. It is math, it is just not a polynomial. And the violation here is having x to a fractional exponent. Okay, so those are all things that are problems as far as being polynomials. In question 2, it says evaluate the following polynomial at the indicated values. So what I would suggest for this is putting this on your calculator in your y equals. So once you put that in your y equals, then you can just find the values of each of these, either on your table or from looking at graphs. And so I have, for the first one, I have negative 9, and then 1, and then another 1, and then negative 3, and negative 5, and then 1. So you can just plot these points. Before I even went to the stage of plotting the points, I would think about the end behavior of this function. And so since we're looking here, our degree is 3, our leading coefficient is positive 1, and so that means my ends are going to be like that. So plotting the points that we have gives us this little thing that looks like some measles or something, and then I know that my ends need to look like I just mentioned. So I'm starting down low, I'm going to come up here through those two, come down like that, and be like so, something along those lines. If you're more nervous about drawing, just plot some more points, even if they aren't asked for. You can always plot extra. Okay, in this next question, I circled the term that is the term that contains the highest exponent. That highest exponent is what is called the degree. And so I've located that on all 3 of the problems that you have. And then EB is used here as an abbreviation for end behavior. So that's all that means. So on the first one, since the degree is odd and the leading coefficient is positive, I know that the end arrows look like this. On B, since the degree is even and the leading coefficient is negative, I know that the ends go like this. Well, I'm in the neighborhood. I guess I could identify the leading coefficient as being negative 1/7. The previous question, the leading coefficient is 31. On C, the leading coefficient is negative 1, and the degree is odd. And so that means my ends are going to go like that. So now I just need to go in and translate that into like regular math words. So this is saying the left-hand arrow. So the left hand is going down, whereas the right-hand arrow is going up. This is asking me for my left-hand arrow as x goes to negative infinity, and that's going down, and so is the other side. And then here, as x goes to negative infinity, that means as x gets smaller, y is getting bigger. That's this arrow. And as I go to the right, my y values are getting smaller. Okay, if you want more, the next video will have the next few answers.